Hello, my name is Jim Dolan. I'm the Vice President of Operations at Shram Incorporated, a manufacturing facility in Westchester, Pennsylvania. What you see behind me is the T500, which is Shram's newest entry into deep hole drilling in the Marcellus Shale and Utica Shale fields. This rig is capable of drilling holes as deep as 15,000 feet and will be an excellent addition into private industry's exploration for oil and gas in Pennsylvania, New York, and Ohio. What you see here, we have actually built in Westchester. It's a heck of a thing. It's 500,000 pounds of equipment, maybe as much as 600,000 pounds of equipment, and it will pull back about 500,000 pounds of tools that will be used to drill oil and gas wells in deep and shallow formations. This thing was built here in Westchester. It was also designed here in Westchester. And it's just a remarkable feat that we've been able to produce in about the last 12 months. Also, it required about $5 million worth of capital investment in plant and equipment in order for us to bring this piece of equipment to market. Now we'll go in to see how we actually put this thing together here in the Westchester plant. We'll first start with our fabrication department, where we were able to put together the white mast that you see behind us. The mast is actually the derrick that supports all the weight in which the drill string or drilling rods are used to drill the deep holes in the shale formations. At Shram, we fabricate a lot of our own product. As you can see here, we are building a mast similar to the white mast that you saw on the T500. All the parts are either tool grade steel or mild carbon steel that we're able to put together. A mast like this will take us in the neighborhood of 120 man-hours to put together. This mast in particular is capable of lifting a load of approximately 96,000 pounds. What you're looking at now is a mast for the TXD. This mast is used the same way as the T500 mast is, except that instead of lifting 500,000 pounds, this mast is only rated to 200,000. As you can see, what we are able to do here is we weld a lot of parts together. You have a saddle, a few tubes, and several structural pieces that go onto this mast. By rotating it, we can always keep the right position, which allows us to have a far better quality weld. These welds are inspected by an outside source and are required as part of our API certification. This machine here that you see, the rotator, we purchased for the T500. And if you notice, we also had to sink it on rails so we could move it in more than one direction. As we do that, again, that allows us to maintain a very good welding technique, which causes the mast to be far stronger. The rotators themselves cost about $250,000 when installed. At Shram, not only do we weld, but we also fabricate a lot of the parts that go into the weldments. This piece right here will be welded onto a mast and is made in a 515. This 515 is a vertical mill with about 60 tools in the changer. We're capable of doing a lot of repetitive work at a very good, very economical cost. By doing this, not only are we able to make the parts a little less expensively, we're also able to respond very quickly to the needs of our customers. This machine is called a plasma cutter. It allows us to make intricate shapes and many varied intricate shapes in a very quick manner. The plasma cutter at this thickness can cut at a rate of about 60 inches per minute. It allows us to also have a very precise geometry, which eliminates the need for secondary operations. If you take a look at this piece below, earlier today you can see we cut out several different shapes. You're able to nest all these different parts on a same thickness plate for use in a myriad of different configurations. So this plate and all these parts might be used on 5 or 6 different rigs. What you can see here is that it has a lot of irregular corners. You could of course put a chamfer on it. You could also put on it any kind of a radius. But here, this gusset, which it probably is, will be used to strengthen a mast or any other steel fabrication that we'll be assembling a little bit later today. This is the power unit or the base unit that will use the mast that we just saw down in the fabrication department, the mast that was on the rotator. This has a deck engine and a cooler. When we go up to the hill and we see the T500, you'll notice that the power unit up there has 2 deck engines and 2 coolers, and of course the associated hydraulics that go along with it. Each one of these deck engines is about 760 horsepower, which, if you think about a typical car at maybe 200 or 300 horsepower, that's 2 cars have got the same capability as one of these engines. One of these engines alone is able to have about 200,000 pounds worth of pullback, and you know, when we do the T500, we have to use 2 engines, not only because of the pullback, but also because of the other functions that are on the rig. You've got a lot of hydraulic power that you've got to generate with these engines. Over on the other side of the plant, you can see another rig. That rig over there, the green one, will be actually shipped down to Chile, and instead of exploring for natural gas, it will be used in the exploration for copper, gold, and other minerals. This rig will receive that mast, and if you notice, that green mast over there is pretty much the same mast as we saw the 2 operators welding down in the fab shop. That mast there will lift about 93,000 pounds of drill string. This takes us about 2.5 weeks to build, and then we'll go ahead and we'll ship that either to Chile or to Africa, to China, or even to the western part of the United States, although most mineral exploration is now done overseas. This white rig is very similar to the green rig that you just saw. If you notice, what we do is we build up a frame. This frame we built in our fab shop. We put the deck engine on it. We put all the hydraulics on it. Of course, we put the cylinders, and over there is another cooler as well. This frame, after it's fully assembled, will be painted, and then after it's painted, it will be placed onto that international truck frame over there. Essentially what we do is we'll buy a truck from International, and then we'll build everything up around it. So right now the gentleman's welding a few what we call outriggers, which will stabilize that truck as it's drilling its deep hole. One of these trucks and one of those decks, very similar to the green one, is what was able to rescue the Chilean miners a couple of years ago. They actually were responsible for drilling the exploratory holes that first found them and later fed and supplied water to the miners for the 70 days that they were trapped below surface. This mast, which again was built in our fabrication department, will be picked up in a few minutes and will be placed on top of the green truck. It will then be welded down using these bearing blocks. These bearing blocks will actually be welded to the top of the truck. And actually what they enable the truck to do is that it allows the truck to stay still, and of course the mast can pivot using these bearings. So what we'll do is we'll raise the mast and we'll lower the mast, and these things right here bear all that weight. We're back outside now with the T500. What you see in front of you is the T500, and it's made up of several different parts. You have a left and a right side elevator, a center platform, you have a power unit, you have a mast unit, and over there is a pipe handler. In the distance you can see a big red crane. That big red crane was only needed to put this thing together. We had to spend almost $500,000 just for the crane in order to put the mast on the unit and also to put some of the unit parts together. What we're doing right now is we're about 3 weeks into a 4 or 5 week test cycle. We are proving out all of the functions and all of the capabilities of this unit before we send it to our customer. Our customer, a company called Alpha Hunter, will actually use this in both Pennsylvania and Ohio to drill for natural gas. Every rig that Schramm produces is subject to a pretty detailed scrutiny. We test anywhere from 5 to 7 days. We make sure that we can pick up the loads we advertise, and we're also trying to ensure that we have the reliability. Interestingly enough, talking about reliability, if you look over that way, you can see a series of large boxes with a Greco on it. What that is, it's a 1600 watt generator that's powering a test machine that is verifying the life cycle of the real guts of this machine, which is called the top head. We're spending about $40,000 per month to rent those generators, and the test device inside that building cost the company about $900,000. Again, what this does is this verifies the fact that we will enable our customer to pull back 500,000 pounds and do it reliably for years to come. This thing will see about the equivalent of 10 years of life cycle on it before we say that we have completed our test cycle. Inside that white building is the control room. The control room is really the heart. This rig, which is a lot different from most of the rigs that we produce, has what's called electric over hydraulic valve systems. So you have a bunch of joysticks in there and computer screens. The days of the manual throttling are over. Everything on this rig, or very much on this rig, is hands-free. And you think about that, what it takes is about 2 or 3 people to run it, and we place no one in harm's way in either handling pipe or in the drilling process itself. It is going to be a remarkably safe rig to run, and it's also a very quick rig to run. You'll be able to handle pipe in a matter of seconds from the ground, as opposed to having to place it up onto the superstructure of that rig. By the way, that rig will actually fold down for transport, so instead of having the 30 or so feet that you have it in the air, it'll be down at ground level and will have a height of maybe about 6 to 8 feet for transportation. But again, each one of those structures there, and there's 7 of them, weigh about 80 to 150,000 pounds, depending upon the structure. In order to get that control room and drill floor trailer in the air, what you have is a hydraulic structure. This structure operates, there's actually 2 of them, and there's a left and a right, and there are 4 hydraulic cylinders on that. Each of these telescoping cylinders causes this whole structure to cantilever up, and it swings up and it supports the entire weight of the mast, of the drill floor, and of course all of the drill string that's down in the hole. So at any time this thing may see as much as 1 million pounds of force, which is the structure itself plus what you have down in the hole. It's a heck of a machine, and it is self-erecting. So what happens is that with a couple of levers, this thing, which folds up and folds down at the drill site, can erect itself in about an hour's time. What's even more impressive is that it walks. This thing can actually position itself to within 2 or 3 inches of a location that you want to get to. It's that precise. The other day, you can see the black drill string, which is actually in a hole that's about 1,200 feet deep. The other day, that hole was pre-drilled, and the other day we had to move the center line of that drill string to meet the center line of that hole, and we were able to do it within about a half an inch actually of center. It's pretty impressive to watch. This is the power unit. This supplies all of the power that's required to hydraulically operate the drill rig. As I said down in the assembly department, on this rig we have 2 750 horsepower engines which supply all your hydraulic pressure. We also have 2 coolers. We also have almost 2,000 gallons of hydraulic oil circulating throughout this entire system. This tank alone has approximately 1,200 gallons of hydraulic oil in it. This is a hydraulic unit, and the only way that you have power transferred to the drilling operation is through the hydraulic pumps and hoses that are an integral part of our drilling system. And of course what they do really is it causes the mast to go up and down, and it also causes the top head, which is the drilling device, to power the drill string through the drop. The interesting thing about our hydraulic rigs is that you also have, besides pullback, you also have 80,000 pounds of hydraulic force downward, which is not available on conventional rigs, and you also have 35,000 foot-pounds of torque, which allows the drills to go through some pretty stubborn drill formation and rock formation. The interesting part about the concrete pad that we're standing on is that it's approximately 1 acre in total dimension, and it's also 3 feet thick. It took 800 cement trucks, loads of cement, to pour this platform that we're standing on today. We did it over the course of about 3 weeks, and we actually used a cement plant's total output for the day on about 6 or 7 days. What you're looking at is the bottom of the drill floor, and this is the way it would look at a drill site, where the drill pipe would actually be coming from the top head and would be rotating and going down and creating a hole in the ground. We of course have a pre-drilled hole here in order to do the testing or the simulation that we have to do. What we're trying to do is make sure that we understand that we can in fact pull back that we can in fact rotate, we can in fact develop the torque that we need to develop. And the really interesting thing is as you can see, if we have a hole here in the ground, we had to have this very large device pretty much right on as far as the center line of the drill floor and the center line of the hole. And that was done through these things right here, which allow our rig to be positioned. Okay, this moves it freely moves. So not only can it move in straight lines, but it can move on a diagonal. And you can actually rotate the whole thing, moving the back and or the front independently. It allowed us to move the other day from about 3.5 inches off the center of the hole to be right on it, and allowed us to then drill and test our rig. What we have here is the LoadSafe. The LoadSafe allows us to handle drill pipe without using our hands. The operators will place drill pipe on this device right here. This device will actually lift up and will roll a piece of drill string or casing into the trough. The trough then elevates in order to meet the mast and the top head. This allows us to handle as much as 24-inch in diameter casing that weighs about 10,000 pounds per piece of casing. And that's just about the best there is in the drilling class. So this thing is almost revolutionary. Again, it's kind of neat because it's on the ground and you never have to actually lift drill string or casing into the air other than using this device, which actually presents the casing or the drill string to the top head for immediate entry into the hole. You can have as many as, I believe, 10 pieces of drill string on each side of this at any given time. And by the way, not only does it load, but it also unloads. So thank you for coming to Shram today. We hope that you've enjoyed our plant tour. It's really a very interesting place to work. And what's more important, that myself and the 250 plus people who work here are very proud of what we've been able to accomplish in the way of producing a rig that will be used not only in Pennsylvania, but probably throughout the world, as is a lot of our other equipment. And again, thank you very much for joining us today.